Sometimes.
Because I can't see it on here because it's small.
Because,
Was it better when it was
I think you might have to come
It was
closer,
a little bit.
closer.
Well, I zoomed it in this time.
I feel like
It's a
we're so
different lens.
separated.
sometimes I have to like trace her hand.
Yeah, it should pick it up. It should pick it up this time. This is a different lens.
All right, so the first problem in the assignment is kind of leading into the next thing that we're going to talk about, or the probability distributions, just two. And so you have probability that x is equal to x is k times 2/3 to the x for x equals 0, 1, 2, find value of k. So if you have probability that x is equal to x, and do we understand that? Like probability that x is 1 and so forth, k times 2/3 to the x, where x goes from 0, 1, 2, dot, dot, dot. So the probability that x is 1 is k times 2/3, right? Oh no, 0 is k times 2/3 to the 0, which is just k. Probability that x is 1 is k times 2/3 to the 1, which is 2/3, right? Yes? Probability that x is 2, I need some feedback here. Are we understanding this?
Yes.
Okay, so k times 2/3, that's k times 2/3, k times 2/3 squared. Now, do we get that?
Yes.
The key is that the sum of the probabilities has to be equal to 1, always. So what is the sum? It's k plus 2/3 k plus 2/3 squared times k plus dot, 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 and that has to be equal to 1. And this is what kind of a series? Oh my God, I have to remember something from pre-cal. Infinite geometric series. It converges because the common ratio is less than 1. And it converges to what?
1.
No, what's the sum of an infinite geometric series?
And plus
A sub 1, which is k, over 1 minus 2/3, and that's equal to 1, because that's what we're given. The sum of the probabilities was 1. So I solve this for k, I get k over 1/3 is equal to 1, k is equal to 1/3.
Is it your pen?
Yes, it is.
About to say
I really am embarrassed to say that's my pen, because I don't usually use like cheap pens like this.
No, it's okay. I lose so many of mine, like they all are cheap.
All right, do we understand that problem? Yes?
Yes.
All right. Number 2, in a game, a player rolls a biased tetrahedral die. The probability of each possible score is shown below. Find the probability of a total score of 6 after 2 rolls. All right, again, the sum of the probabilities has to be, oh no, I'm doing this differently here. Yeah, the sum of the probabilities has to be 1, right? So if I add 1/5, 2/5, 1/10 plus x, what's up, Momo? Why are you talking to?
You asked me how you know the side of that.
Oh. Have you never seen a tetrahedral die?
It's like a pyramid.
Yeah, it's like a triangle pyramid.
It's like a 3-dimensional diamond is what it's kind of like.
That's how I can kind of see it.
Yeah. Do we have a?
Wouldn't it be more like a pyramid?
No.
I
I mean, that's not really important.
Because a pyramid has 4 sides.
No, for pyramid's gonna. Well, it depends on what your base of your pyramid is. But yeah.
But the base of the triangle.
Do we want to see it?
Yeah.
I'm kind of curious.
The beauty of technology right now. Let's Google it. See, here I am like like talking about probabilities is typical. Like, this is what I love about you guys, because you're just so honest, and like we're talking about, you're not concentrating on anything I do. Andrew's just going, what does that look like? I wish I could have, you know what would be really cool is if you had like electrodes tied to your brain, like taking brain impulses and stuff. And that like, in that T-Inspire, also everyone the TI-Inspire, everyone that has their calculator logged in, on my screen I'll be able to see their screen. So if someone's screwing around, playing a video game or whatever, you can see all these screens. Well, what would be bitchin' is if I could see everyone's brains, their thoughts of what's going on during my class. Because it's like, I'd be going, stop thinking about sex. What are you thinking over there? What are you doing over there? You're thinking about your English essays. Tetra, hedral, hedron.
Hedral dye.
All right, let's just go tetrahedral shape.
Could you write a program where the Inspire could take attendance for you?
Yeah, like you keep like
Can you
keep
see
track
that?
of when people
It's
log
a
in.
diamond. It's like a pyramid.
It's kind of like a, yeah, it's like a pyramid-ish thing. I don't, I can't make it bigger. Let's see. I have one of those, that's not it.
Just four.
Can you see that?
Yes.
Yeah.
All right, let's do this. Right there. That's it. So 1, 2, 3, and then the back side is 4. When you log in, when you have these TI Inspires, when you log in, I get this little screen that has everyone's name and a little like picture of a face. And so I can tell if they're logged in because their little picture becomes green and the people that aren't logged in are red. So yeah, you actually can take attendance that way. It's pretty cool. It is really, really cool. It's kind of scary though. It's kind of invasion of privacy at some level.
And you want to know our brains.
Huh?
And you want to know our brains.
I know. Well, I don't really want to know your brains. I think that would be cool to like do for one day. Because then I'd find out, oh my God, no one really is paying attention to me. Verification.
Aren't there like 2 waves of thought in your brain at the same time?
What?
Aren't there like 2 like waves of thought in your brain at the same time? No.
Only 2? Hopefully there's more going on.
Like at the same time. Like,
Ways of knowing?
do you know what I mean?
No, I
Like
think
you're thinking
there's.
about 2 things at the same time.
Are you doing that TOK thing on me, or
No.
are you TOK me?
I think it is.
No. Actually, Koo was like yelling yesterday because someone, or 2 days ago, because someone, what was the article? Who was there? X, were you there?
That guy talking
was-
about how men
Or
don't come out about
men don't speak out about
birth control.
birth control.
Men don't speak out about birth control?
For birth control. And I
For
said,
birth
I
No,
said,
no,
yeah, of course we're not. Like, as soon as you say something, you sound like a jerk.
Yeah, well, you're probably right. Like, men have no business of,
Yeah.
coming from a woman. It's like, I just think men have no business commenting.
Oh,
on
he
that.
got heated because like the woman wrote the article said like middle-aged men don't talk about fetuses, and then he's like, me and my friends talk about fetuses sometimes.
I don't know if I admit that, Mr. Coop. In public.
He like started yelling.
Does he's like a fundamentalist Catholic, isn't he? Like diehard,
He's
isn't he?
political. He's supposedly he's like intern like.
All right, let's get back to our tetrahedron tangent. So the sum of all the probabilities have to be 1. So x has to be what?
3/10, 7.
3/10 or 7/9. Those are quite different.
What?
X is 3/10. 1/5 plus 2/5 1 plus 2/5 plus, so 2/10 plus 4/10 plus
1/10.
Yeah.
7/10.
Okay, so it's 3/10, right?
Yeah.
All right. Then I've got to go, what's the probability of getting a score of 6 after 2 rolls? So I can go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6.
But there's only four.
Yeah, there are only 4 sides of the die, so you don't have to go.
Oh, yeah. Yeah, that makes it easier. Okay, so the sum here is going to be 2, 3, 4, 5, 3, 4, 5, 6, 4, 5, 6, 7, and 5, 6, 7, 8. And what do I want the sum to be?
6.
6, 6, 6, 6.
It's
Okay, so I can get a 3 on the first and a 3 on the second. Or I can get a 4 on the first and a 2 on the second. Or I can get a 2 on the first and a 4 on the second. Those are my only ways that I can get a 6, sum of 6. Do you all agree?
Yes.
All right, so what's the probability of getting a 3?
1/10.
So this is going to be 1/10 times 1/10. Because I have to get a 3 and a 3, right? And they're independent, so I can just multiply. Plus the probability of getting a 4 is 3/10. And the probability of getting a 2 is 2/5 or 4/10. And the probability of getting a 2, 4/10. And the probability of getting a 4 is 3/10. So that's 1 100 plus 12 100ths plus 12 100ths is 25 over 100, which is 1/4.
Wait, why can't we just say there's 3 of them?
There's 3 what?
So there's 3 6s out of 12.
Oh, that would have, no. What do you mean 3 6s out of 12?
Well, because the dice are biased, it's not an equal chance that you'll get a 1, 2, 3, or 4.
Right, yeah, it's a biased.
Oh,
So it just happens.
oh never mind. It's 3 out of 16
Okay.
anyway. It's not wrong.
Yeah, 3 out of 16. All right,
Big
number 3. Everyone should have been able to do number 3, right?
Yeah.
Binomial random variable where the number of trials is 5 and the probability of success is p. Find the value of p if probability that x is 4 is 0.12. So how do I do that one? The probability that x is 4 is what?
5 choose 4
Times,
P to
P to
the
the
4,
times
1 minus
1 minus p.
1 minus p to the
First.
1.
equals.
And we're given that that's 0.12. All right, so I think 5 choose 4 is 1.
No, 5 choose 4 is 5.
Okay. P to the 4th times 1 minus p. 0.12 is equal to 5p to the 4th minus 5p to the 5th. And I go 5p to the whatever. I solve this using your calculator, like graph it, or you can use polynomial solver or whatever. And you get 0.459 or 0.973.
Just put both or small.
I think you have to put both
Why would you get 2 values?
because there's 2 solutions to that. Equation apparently. Because it's like a 5th degree polynomial that's crossing the x-axis at 2 points, basically. Okay?
So do we mark one off or do we just leave both numbers?
You leave both numbers.
Wait, this is...
0.459 or 0.973. That's what I have. Okay, in the assignment, number 1 is 0.165.
Hold on.
Number 2, A is 1200, and B I forgot to tell you. The expected value is n times p, and the standard deviation for a binomial is the square root of np times 1 minus p. Okay, that's a formula. Standard deviation is the square root of the variance, and so that's the variance. Let's see if that is in your formula sheet. Oh, they give you all kinds of good stuff for statistics and probability. So they give you the mean, the variance, the standard deviation, all the formulas, the sample statistics, probability, conditional probability formulas, expected value for discrete, binomial distribution. They give you everything here, okay? But they give you the variance. You need to know that the standard deviation is always the square root of the variance. Got it? All right, so if you use that formula, then you get 20. Please make a note of that in your notes or something like that, okay? Number 3, A is n choose 2 times 0.4 to the second times 0.6 to the n minus 2. And B is by trial and error 10.
Is there any other way?
I don't really know of any other way. Well, yeah, there is some other way. And that is to use the definition of n choose 2.
And factorial over factorial.
Yeah, yeah, but that's a nightmare. Just use trial and error. Okay. Number 4, A is 0.1 and B is 4. Again, you wouldn't have gotten, well, NP, the mean is the expected value is 0.4, and then you set that equal to, I get 0.36 is equal to NP times 1 minus P, and that's how I get P is equal to 0.1. Do you want me to go over that? Trials are independent. Probability P of success is constant. Let X be the number of successes in the n trials. The mean of X is 0.4 and the standard deviation is 0.6. So basically I take the standard deviation 0.6, square it, you get 0.36. Set that equal to NP times 1 minus P and plug in your your MP. Yes or no?
Yes.
Okay. B is n is equal to 4. 5A is 2.5, because I just multiply n times P. So the expected number of yellow ribbons selected is the mean. Expected number is the mean. B, probability that X is 6 is 0.0162. Probability that X is greater than or equal to 2 is 1 minus the probability that X is less than or equal to 1. And that is 0.756. And D, find the most likely number of yellow ribbons selected. Well, I didn't understand what they wanted there, because the most likely number of yellow ribbons selected is the expected value, which is the mean.
So maybe, I think they were trying to go for is like, you can't get half a ribbon out of there, so.
Okay, I understand that. So what they did was they put a table, and they said if X is 1, the probability is 0.188. If X is 2, the probability is 0.282. If X is 3, the probability is 0.250. So it started going down from there, so they said the expected value are most likely to get 2. Alright, so let's just kind of make a mental note of that. If we get a decimal for an expected number of ribbons or expected number of some discrete value we should have, then we can just do a table of probabilities and look for increase to decrease. E is, what assumption have you made about the probability of selecting a yellow ribbon? That it remains constant. Number 6 is 0.913. And number 7 was a repeat of another problem. Number 8, A is 0.0287.